we might have heard what is big data. These days we were hearing it very frequently. What is it? So big data is something that which is very huge in volume and is not able to be processed by our existing traditional relational databases or any other means of it. Okay, and there are projections by IDC saying that by 2020 we will reach around 44 zettabytes of information. Zettabytes of information means it will be around 10 to the power of 21 bytes. It's almost like I can tell you one sample example for that. If you keep writing all that current data into CDs or DVDs, and if you put them as a stack of DVDs, it will reach the length of distance between moon and earth. So this is that much big. Okay, and there are various sources for big data. Like you can see like Facebook, which is generating 6 billion messages per day and around in terms of terabytes of information per day. And there are trade markets, stock exchanges, and sensor data, and even user web pages. There are many sources of data generation for this big data. Okay, what is the problem with existing tools? Existing tools as in the sense any RDBMS, traditional RDBMSs like Oracle, Teradata, MS SQL Server, or any other processing tools. The problem is one thing is cost. As the data size increases, they need to increase the processing capacity of the servers. Here, one thing is, first thing is cost. Second thing is scale up approach. Scale up approach as in the sense, if you have 1 terabyte or 1 TB of data inside your Oracle database, and if you expect like in another 2-3 years, it is going to be doubled. And whatever the processing capacity now you are using, if it is costing like around 50 million or something, to increase the processing capacity, it will cost around 10 times of your current cost. Because that you can compare with the basic commodity hardware itself. If you want to buy 4 GB RAM, it might cost around 2,000 rupees or something, or 3,000. At the same time, if you want to buy the 8 GB, it will become around almost like 4 times. It will be like 16,000 or something. So that is the difference between scale up and scale out approaches. Scale out approach means something which is improving the performance by keeping your hardware linearly. That means having 2 4 GB RAMs. To buy 2 4 GB RAMs, it will cost around 4,000 for you. But at the same time, if you want to buy the same 8 GB RAM as one unit, it will cost you around that much, 16,000. So that is one thing. And second thing is when processing data, if you have only one machine with you and one network bandwidth with you, the data input output transfer rate will be limited up to a certain value. Okay, whereas if you have multiple machines connected to your data, you can process and you can search on that data, you can index on that data parallelly by so many machines, because they have their own bandwidth and their own input and output channels connected to the data source. Okay, so that is the notion behind our Hadoop. Hadoop is it's an open source framework contributed by various sources. Okay, various sources, as in the sense the creator of Hadoop is Doug Cutting, who was one of the engineer and working at Yahoo initially. He provided an open source framework written in Java, which is for processing on distributed file system. Okay, main features are like it can process the big data on clusters of commodity hardware. You don't need to buy any high-end configuration machines or servers for this. Okay, you can even work on the normal desktops, normal laptops connected together, and we can make a cluster out of it. And this is the job trend on Hadoop technology. This was taken in January 2012 or so. By this time, anyways, in the beginning of 2015, even Indeed and everything has projected like there are Hadoop jobs percentage is greater than any other technology. Even in US market, it's growing like anything. Okay, these are some of the big companies which are using Hadoop as of now, and there are many small other companies as well. Mainly the initial days, it was evolved from Yahoo and Google. Anyways, it's using its own version of Hadoop FS, which is called GFS, Google File System, and its own processing frameworks. Apart from that, everybody else are using the basic Hadoop framework only. Yahoo, Facebook, LinkedIn, Twitter, Amazon, all these are using. And most of them, everybody will have their own names for their distributions. IBM has its own Big Insights, and Microsoft has its own like a HD Insight, and LinkedIn has contributed few tools to Hadoop ecosystem like Kafka or Storm, and Facebook has contributed some of the tools into Hadoop ecosystem like Hive. Okay, so this is one of the example we can think of. Why do we need parallel processing? In early 1990s, one normal desktop machine was able to store just 1400 MB of data into its hard disk, and its transfer rate, network IO channel capacity was like 4.5 MB per second. And to read the entire hard disk or search the entire hard disk for one particular string or something, it was taking around 5 minutes. Okay, whereas if you see these days, we are getting the laptops or desktops with 1 TB of hard disk capacity, and now the bandwidth, IO channel bandwidth capacity is 100 MB per second. So with this speed rate, if we want to read the entire 1 TB of drive, it is taking around 3 hours of time to search on a particular string. Okay, so that means just to read inside 1 TB of data, if this is going to take this much time, and even if you increase the RAM capacity or processor capacity and bandwidth capacity, it is taking around 10 minutes of time, even with the latest configuration available in the market. So what if I have to search this very quickly within 2 minutes or 3 minutes, then I have to go for the parallel processing. So that's where the Hadoop fits in, and that's where the Hadoop solves our problem of processing the big data. Okay, so Hadoop cluster is nothing but, it's a cluster means a collection of nodes connected together in the same network. Okay, they can talk, they can communicate with each other. So in this cluster architecture, there will be multiple machines connected in the same network, and they will all process the data together, and they will split the processing capacity and data storage capacity as well. If you suppose, like, if you want to store 1 TB of data across 100 drives, 100 machines, so it is, to read 1 TB of data on one machine, it's taking 3 hours. So if I want to read the same thing in with 100 nodes, it is taking to 0.03 hours. That means around less than in a minute. Okay, one more advantage is that here you don't need to go for the high-end configuration servers, which will cost so much, and they will take a lot of licensing price also. So instead of that, you can scale linearly, as in the sense you can put your normal desktops and you can attach them in a network, and you can increase the bandwidth by that your extra node. Okay, Hadoop cluster is a set of cheap commodity hardware. Cheap commodity hardware, as in the sense your normal desktops or laptops. Usually we will go with a 16 GB RAM or 1 TB or at least 6 TB or 12 TB of hard disk. Hard disk can be even more than our normal desktop, but your RAM sizes can be up to 16 GB or at maximum of 32 GB into your data nodes and so on. Okay, and they all are networked together, resides in the same location. If these are the, suppose, like, I mean, these vertical stands, or each vertical stand represents one rack in Hadoop cluster. This is one rack, and this is another rack. This is another rack. Each rack will contain multiple nodes. One node, as in the sense one computing node, one processing node. Processing node, you can treat one processing node as equivalent to your desktop. Set of servers in a set of racks in a data center, that is called a Hadoop cluster. Usage of commodity hardware, cheap commodity server hardware. No need for supercomputers, which is having 1 terabyte of RAM or i24 or i68 core processors. These kind of configuration not needed when you compare to Teradata servers or Oracle servers, which you need when your data grows. Okay. So this is something what we are discussing about scale out and scale up. Scale out is something scaling linearly. That means if you are not able to solve your problem with one desktop, put one another desktop beside it and connect them together. It will increase the processing capacity by double. But in the scale up approach, you have to increase the hardware configuration within the single machine, single server. Suppose earlier you are using 16 GB of RAM. Now, if you want to increase double the processing capacity, you have to use the 32 GB of RAM, one single RAM in one server machine. And earlier, if you are using i7 processor, now you have to go for i14 core processor within the same server. So there is some hardware configuration limitation available in the market as of now. So it is easier to buy two machines with i7 processors and 16 GB RAM than going for one i14 core processor and 32 GB RAM at a time. So if you scale vertically, that is called a scale up, and if you scale linearly, that means having one more similar configuration machine, connected to the existing machine. That is called scaling linearly or scaling horizontally, or we also call it as a scale out approach. And scale out approach is the cost effective when compared to scale up approach. And one more, the biggest advantage with the Hadoop principle is that here, if you have 1 TB of data in your Teradata or Oracle servers or anywhere with the existing traditional databases, if you want to process that data, you have to pull that data to the processing node. Wherever the processing configuration is present, to that location, you have to transfer your data, and on that location, your data will be processed. That means you are bringing data to the processing node. But in Hadoop ecosystem, we will do that in reverse. We will transfer our processing capacity to the place where the data is residing. Okay, that means, bringing code or processing capacity to the data is relatively smaller when compared to the original size of entire data. Suppose like if you want to process 1 TB of data and you are running some 1 MB of code on top of 1 TB data. So it would be better to copy the code to 1 TB data, because copying code 1 MB code to a node where the data present will not take more than 1 minute, because it is just 1 MB of size. But whereas if you want to copy that 1 TB of data to a node where 1 MB of code present, there it will take at least in terms of minutes, even if you are going for parallel processing. Okay, that is the one more advantage, where bringing code to data rather than data to code. Okay, and dealing with failures. Since we are using commodity hardware like normal desktops, there is a more chance that network failures or hardware failures or any other chances. And the Hadoop will provide you the mechanisms to recover automatically, or it will suggest you the ways how it can recover. Okay, and it will abstract the complexity of distributed mechanism and concurrent applications. It will just show you, you will not feel it like it's a complex distributed system. You will feel it as like a one single machine serving for you. And this is something what we have discussed, scale out instead of scale up. It is harder and more expensive to scale up, add additional resources to an existing node, or that is resources as in the sense we always talk about in terms of CPU and RAM only. Scale out approach is nothing but adding more nodes or machines to an existing distributed application. Software layer is designed for node additions or removal. Hadoop takes this approach. Very easy to scale down as well. It's just removing those additional machines from the network. And this is something what we discussed about code to data and data to code. Traditional data processing architecture, suppose this is my processing node and where I have 1 MB of code which needs to run on my 1 TB of data, and this is my storage node. And here I have 1 TB of data. In traditional RDBMS, we were loading that data from storage node to processing node. Here again, so that means here also you need the same capacity of storage to get this data to here. And it was running that 1 MB of code on top of 1 TB of data. And finally, it was saving those results back to your storage node. That is what happening inside our traditional data processing architecture. So if you take this in Hadoop ecosystem, you will have your processor or processing node on each storage node. That means you are moving your processing capacity to your storage nodes. So suppose this is having 250 GB data and this is having 250 GB data, and these are also same. Now I have my processing node moved to all storage nodes. Here, so when compared to the previous architecture, here I have 4 processing nodes which can run parallelly, and even your data storage got distributed across different storage nodes. And it is, suppose if you think like it is evenly distributed and your processing capacity is also evenly distributed, then in order to process this much of data, if it is taking like 1 hour, this can be completed within 15 minutes. Okay, and that too, here data transfer time is not needed because we are not transferring data from one node to another node. Since we are transferring the code and processing capacity to the storage node itself. Here, code is moved to data. The code will be very tiny, usually in KBs or MBs at max, even if you have any external jar files or any external required libraries. Processors execute code and access underlying local storage data. And finally, your results will be stored in this machine. Results from this data storage will be stored in this machine, and results from this will be stored in this local machine. And same thing. Here also, the results will be stored in this local machine. Finally, after completion of processing, it will collect the results from all the machines and it will put that into your HDFS file system. Okay, failures are common as we are using common commodity hardware. In this case, we can simply replace or remove that data nodes which are facing failures or any issues. And Hadoop is designed to cope with the node failures, like data is maintained in more than one copy of data, because even if some nodes goes down, there should be a chance that you can get the same data from other data nodes. Okay, by default, Hadoop maintains 3 copies, 3 replicas of each data file. Okay, that means even if one data node or one node goes down, there will be 2 more copies on the cluster. And sometimes even if tasks are failed across your nodes, processing tasks, so they can be retried on different data nodes. Abstract complexity means Hadoop abstracts many complexities in distributed and concurrent applications, defines small number of components, provides a simple and well-defined interfaces of interactions between those components, frees developer from worrying about system level challenges. We don't need to worry about race conditions or data starvation or any kind of allocating resources to your job or task. The Hadoop framework itself will itself look for what are the available data nodes, what are the available nodes which can store the data, or what are the available nodes which can process the data. These kind of decisions will be taken by your Hadoop framework itself. You don't need to worry about all those things. Low level management is not needed by you. Okay, it allows developers to focus on the application development logic itself. You don't need to worry about the management of your resources. Okay, or it will not, you don't need to worry about your resource management or your failure management also. It will take care of on its own. Okay, this is something about history of Hadoop. It was initially developed based on the Google white paper released on Google File System and MapReduce framework. These two are initially originated from Google only, and later Dow Cutting is one of the employee in Yahoo. In his initial days, he was working for a nudge project, which is called a search engine, which used to index the web pages. It's almost like a leucine. I mean, the background technology used behind that was leucine, and it's something similar to your Elasticsearch or Apache Solar. Okay, based on this, he used this parallel processing framework inside his nudge. How to search or how to index the web pages and how to search those pages. So to search, to provide the searching mechanism, he has used that parallel processing concept, and with that he continued on the parallel processing concept, and he developed this Hadoop framework. Okay, in 2006, Yahoo hires Dow Cutting to work on Hadoop with a dedicated team, and after that, he finally, they finally contributed that into Apache open source projects, open source community. So in 2008 only, it became top level project in Apache. Okay, and finally he was jumped into Cloudera, and now Dow Cutting is working with the Cloudera. Okay, and these are the names, how we come up with these names. Leucine is something, Dow's wife's middle name, which is used for his search engine technology, and Nudge is the search engine tool, which is the name of a word for meal that his son used as a toddler. And Hadoop is the name of an yellow elephant, stuffed elephant, given by his son. They don't have any particular meanings for them. Okay, just the names, funny names given by them. That's it. Okay, comparison between Hadoop and RDBMS. You can treat it like Hadoop is more of like batch oriented system, and whereas your existing RDBMSs can act like online systems. If you want to perform any inserts, deletes, updates to your existing databases, you can do that within fraction of milliseconds. But whereas if you want to do the same thing in Hadoop, it is going to take a bit longer times, because you will have large data sets here, and that too, if you want to perform any activity inside your Hadoop, it will run in terms of jobs, in terms of MapReduce jobs. Okay, MapReduce is something like a parallel processing framework that we will discuss later. So mainly RDBMS is for online processing and Hadoop is for batch processing. And batch RDBMS will give you low latency responses, and whereas Hadoop is high latency response. Okay, the only problem with RDBMS is that scalability. It cannot scale beyond a certain limit. You always have to follow the scale up approach, which is very cost, and that too, you cannot do that beyond certain limits. Okay, expensive to scale for larger installations, hits a ceiling when storage reaches hundreds of terabytes. Hadoop clusters can scale out to hundreds of machines and to petabytes of storage as well. Okay, and one more data type format. When you compare it with RDBMS and Hadoop, RDBMS can store only structured data or semi-structured data. Structured data as in the sense your tables, where you can able to view your data in terms of columns and rows. Semi-structured data as in the sense you can treat examples like JSON data or XML data or CSV data, these kind of formats. Okay, unstructured data means any streaming data like any emails or any log files or any posts or any streaming data from your social media, anything which is not having any structure to that, that can be treated as your unstructured data. Okay, certain kinds of images and videos are also treated as your unstructured data. But JSON and XML data are treated as your semi-structured data. And offline batch versus online transactions. This offline batch is related to your Hadoop and online transactions is related to your RDBMS. RDBMS is best for online transactions and low latency queries, whereas Hadoop performs best for offline batch processing on large amounts of data. And Hadoop can store historical data and it can process on even large amounts of data sets as well, whereas your RDBMS will stack up in processing the huge data sets. RDBMS works best with small records, whereas Hadoop can process the large data sets as well. It is not completely, Hadoop is not something which is completely going to replace the RDBMS or something. Why? Because it's mainly focused on batch processing and large sets of volume of data. And even if Hadoop evolves into market, and RDBMS still is needed because we need online transactions, where if you want to perform something and insert, delete or update or any query, search query on small set of data sets, the RDBMS will give you the faster responses than your Hadoop jobs. Okay, Hadoop and RDBMS frequently complement each other within an architecture. They both are used together in any Hadoop architecture, big data solution architecture. For any online kind of things, we use RDBMSs, and for any batch related or report, OLAP purpose, online analytical processing, we use Hadoop, and as OLTP, we use RDBMS. Okay, so this is something which we can talk about Hadoop ecosystem and what are the tools and what are the different extra other family members of the Hadoop ecosystem. Okay, the main Hadoop core system will contain only two parts: HDFS, which is the file system behind your Hadoop architecture, and MapReduce, which is the processing framework behind your Hadoop architecture. Okay, these two. And anyways, in the later releases, in the current release of Hadoop, we have YARN architecture in place of MapReduce. MapReduce is a subcomponent of your YARN architecture. So this is, one is processing framework and one is file system. This is distributed file system and this is distributed processing framework. Okay, we will see in deep what are they and how they differ, okay, in later sessions. So apart from these two, there are additional tools like Hive, which provides the SQL-like feel on top of Hadoop. You can run SQL-like queries on Hadoop, whereas your MapReduce programming will be mainly in Java only, most of the times. 70% of the times, you need to code your programs in Java, and you can also use other languages also, like Python, Perl, Ruby, or even in Shell script. Okay, and Pig is something like data processing or scripting language, which executes the statements in a scripting flow. Okay, this is also similar to your Hive. These two can be treated as like an ETL tools inside our Hadoop ecosystem. where you can extract the data and transform that as you need, and you can load that back into wherever you want inside your Hadoop file system. Okay, and Woozy is something, a scheduler to schedule your jobs based on time or data availability. Okay, and Zookeeper is the coordination service. Coordination service, as in the sense, it will get to know what are the nodes available in the cluster, and who all can act as master nodes and who all can act as slave nodes. Okay, this kind of coordination between nodes will be taken by your Zookeeper. On HBase is something like it is almost similar to your RDBMSS. It will provide you the online transaction facility. But it is not that much fast as your RDBMS. Okay, so in this ecosystem, you can treat the Hive as OLAP and the HBase as OLTP. So that's the overview of Hadoop core components and the Hadoop, some of the Hadoop ecosystem components. These are not just the Hadoop ecosystem components. There are many components. At least you will find 2 to 3 components on each alphabet. On A, you have Apache Ambari or Apache. On every letter, you will find at least 2 to 3 tools names. Okay, Apache Abro, Apache Ambari. On H, you can find HDFS, HBase, Hive, Hue, many things. Okay, there are around 153 tools available in the Hadoop ecosystem family. Okay, we will mostly concentrate on most of the times HDFS, MapReduce, Hive, Pig, HBase, and a bit of Scoop and Flume. Not bit, you have to use them also to full extent to get your data into your Hadoop architecture. Scoop, Flume, and Oozy. And anyways, Zookeeper, you will not be directly involved in programming of this or something. This is something which will be handled by an administrators. Okay, coordination service, which will be only involved during the time of setup only. After that, you will not involve with that much frequently. Okay, so this is the overview of your Hadoop ecosystem core components and Hadoop ecosystem other components, sub-components as well. So till now we have discussed what is big data and how can we solve that with the Hadoop distributed parallel processing, and how is it different from your RDBMS. Okay, what are the key features of your Hadoop, like scale out, bringing code to data rather than data to code. This is something called data locality. We also call this as data locality. Okay, and how Hadoop, the framework itself, will take care of the failure recovery, and how it will abstract the complexity of distributed and concurrent applications. We don't need to worry about how to make them, how to worry about how to assign the resources, and how to partition the data, how to split the data, and how to run your code on top of your data. Okay, what is big data? What is Hadoop? What are the 3 to 4 different salient features of your Hadoop, and how is it different from RDBMS, and what are the core components of your Hadoop, and what are the sub components of your Hadoop ecosystem. These things we have discussed, and a few points about its history as well. Okay. So, any questions?
I'll open it up for everyone so that if you have questions, you can ask. And one question I have, Mr. Shiva, for all the participants.
Okay.
This is Dinesh. Now, you have explained about the database, the programming, and also the ecosystem. Would these people have to have some prerequisite background to jump into the course where you want to start? Like, what is the prerequisite they need to have?
Okay, so it's good. It's better to have basic Java, core Java programming. That is one of the prerequisites. And if you have SQL background, that would be additional.
Okay. If they do not have Java background, would they get around using Pig and Hive?
Yeah, they will get around it, but most of the times in job opportunities and during their interviews, they will mainly focus on the MapReduce programming and HDFS. But they will also ask the questions on. They will get jobs on Pig and Hive also, but there is a less chance on that.
Okay, so so they concurrently have to get knowledge in Java and maybe build up their existing knowledge in Java and also programming side if they really want to get into this kind of job.
Yes, exactly. And not even, you don't need much of Java skills. You are just sufficient with the basic core Java programming skills like classes, objects, inheritance, and bit of collections.
Okay.
Okay. So there will be around 3 to 4 chapters of it, and even if they are very good self-learners, they can learn it within 2 to 3 days. Okay. And anyway, SQL, even if they don't have, they can learn it within 2-3 days. It's not a big deal. Because there will be around 10 commands only at max in SQL. Okay. And a bit of Linux knowledge is good for them. But even if they don't have, we can take a crash course on that as well for one day. 1 hour course.
Yeah, Shiva, I have one question on that. Do we actually need to know, Linux before using Hadoop or
Yes, we need to know the Linux commands and Linux
just the basic commands, right? Like not in the deep.
Yes, basic commands like ls, put, copy.
Yeah, exactly like that. And one more thing, for running Hadoop on Linux, what we need to install?
I would recommend all of you to install Ubuntu latest 14.10.
Okay.
And I can provide you the instructions how to install them also, or how to install Ubuntu and how to install Hadoop. We can go with either Cloudera or Apache Vanilla Parcels or Hortonworks, anything whichever we prefer or I suggest.
Yeah, I have installed with Cloudera, but I'm having some issues with that. Like I'm not able to run the commands I want to.
So, did you install it on any VM?
Yeah, I have installed it on virtual machine or virtual machine.
So did you download the Quick Start VM for Cloudera?
Yeah, exactly.
Okay. Usually most of the time, 90% of the times, I don't recommend that kind of VM stuff. Why? Because it will always give you the virtual feeling. Okay. So if you have your hardware configuration enough with you, something like if you can allocate 150 GB of hard disk, keep it as a separate drive in your machine. Okay. And try to install Ubuntu or CentOS parallel to your existing Windows.
Okay. I heard that that would erase all my data in Windows. Is it the case?
No. It will be installed as a dual bootable OS.
Yeah, I know, but some of my friends got the problem. They were installing Ubuntu, but they erased all their hardware. So
Yeah. You need to be careful at the time of
yeah,
installation.
exactly.
Yeah, you need to be very careful at the time of installation. Otherwise, you will lose the existing Windows data.
Okay, and
Why?
how
Because
much?
it will show it. It will give you three options actually.
Yeah,
You
exactly. I
want to.
tried installing that. I tried doing the dual boot also.
Okay.
Yeah. It was installed, but it was not running properly, so I had to remove it again. So I'll
Okay.
try that again. One more
Okay.
thing.
Anyways, if
How
you
much?
want, I can provide you that as well. Okay.
Yeah, that would be.
So actually, I prefer that one only because if you go with the Quick Start VM, it will
Mhm.
come up with the all pre-configured box where
Yeah,
you will not
exactly.
be able to see the bits and pieces of it.
Mm-hmm.
Okay. So it's like a trained baby. If you type one command, it will start all the services, and you will not be able to see what is happening exactly at the back end.
Yeah.
Okay, if you start from the scratch, like by installing your own OS, and in 99% of the times in production or even in our development environment, we
Mm-hmm.
use only Linux systems.
Yeah, exactly.
Okay. This is the first time, or I mean, less than 10 times I'm using the Windows machine. Today also I faced some issue in working with the Ubuntu system to log in into this Zoom conference. Okay, I have
Okay.
to figure out alternative mechanism for this to work it from the Hadoop Ubuntu system itself. So then I can show you, I mean, I can install everything on my system and I can show you parallelly so that you can repeat the same thing from your end as well.
Yeah, that would be great actually. I really need
Yeah,
that.
I never go with these kind of slides or something. Okay, this is just to give you the just a feel of it. That's it. I always explain by doing on my machine, and you will be able to see that practically.
Okay. And one more thing, Shiva. How much RAM would be enough for doing the double boot with Ubuntu?
At least try to keep 150 GB of hard disk. Okay, and how much RAM is with you?
It's 8 GB.
8 GB. 8 GB is more than enough.
So do I give full 8 GB to that, or I need to divide between
No.
the
You
two?
don't need to allocate your RAM memory. I mean,
Okay, okay.
you can only load one operating system at one time.
Okay, yeah.
So
Okay.
you can either log in into your Ubuntu or you can either log in into your Windows machine.
Yeah, okay,
So
yeah, I got it.
then entire 8 GB will be consumed by one operating system itself.
Okay.
Okay.
Yeah. Thank you, Shiva.
Yeah, this is just because of overview session. I was not able to touch all those things. Okay. So next section we can see on what is the how to install Ubuntu or something, and even I can provide you the links for them if you can do that on
Yeah,
your own.
definitely. That would be a great help if you can provide that.
Yeah.
Now, Mr. Shiva, we have about 6 people in the session. Now, this like what time is good for you? Is this the good time, like 6:30 PST, like when we?
Yes, let's talk about on this offline.
Okay. So we can now
I have
just for
other
the
priorities as well.
for the participants. What I'll do is I will get in touch with the participants as well, so that I can get their convenient times. But for the on a broader note, if we can get some kind of idea like evenings or mornings, then we can I can pull more people even. So we can talk offline.
Yeah, we can talk that on offline.
Yeah.
Okay. And if
this is Amit.
Yeah, Amit. Go ahead.
Just sorry to interrupt, but I wanted to know what is the approximate duration of this course, including everything.
Including everything, as in the sense you want to go with the basic administration skills as well, or as Hadoop ecosystem components, basic set of components like MapReduce, Hive, Pick, HBase.
What I mean is, what is the training duration? Just the training part.
Okay, so just the training part, if you include the basic set of tools like HBase, Hive, Pick, okay, and into your HDFS and MapReduce, it will take around 40 hours. Okay, and if you want to add on any more tools, it is going to take longer than that.